Oh, and I just realized I was not recording. So, people joining us later, I just finished off fallacies. Okay, so again, people just watching this video right now, the past half hour or so, I've just been talking about fallacies. I've been finishing the Prezi on fallacies. So you missed this right now. Just check out the fallacy presentation itself. Check out the Prezi, and you'll get caught up to speed. Okay, so apologies for not having video for that. Now we're going on with inductive logic. Yeah, they should have come anyway, right? Sorry, people are commenting that you should be showing up to these classes anyway, then this wouldn't happen. True enough, thank you. Okay, now moving on. Inductive logic. Okay, so we learned what inductive logic is already when we learned about deductive logic, because I showed you the difference between them. Does anyone remember what the difference is? You might kind of remember, but it's hard to say it in a succinct sentence, right? Does anyone kind of remember the difference between deductive reasoning and inductive reasoning? Well, I'm not going to wait. So remember, with deductive arguments, when the argument is successful, right, when a deductive argument works, in other words, when it's valid, the conclusion has to be true if the premises are true. Right? Remember, that was the definition of deductive validity. In inductive, yes, it's more like predicting a conclusion with some amount of probability, right? So, whereas in a deductive argument, the conclusion just follows. If the premises are true, the conclusion must be true. Whereas in an inductive argument, if you're to phrase it the way that Anna is, you might say, in a successful inductive argument, if the premises are true, then the conclusion is very likely to be true, right? We might predict that the conclusion is going to be true, but we understand that it's only a prediction. It doesn't follow logically from the premises. So examples of valid deductive arguments, hopefully you have these sort of in your head, right? It's an example from categorical logic. So if you were to do the Venn diagrams, you would see that this argument is valid, right? If you were to plug in all cats are mammals, right? Universal affirmative, all mammals are animals, another universal affirmative, then you would see the conclusion show up, all cats are animals, right? If those premises are true, the conclusion must be true. Yeah, of course, right? If it's really true that all cats are mammals, and it's really true that all mammals are animals, then of course it has to be the case that all cats are animals. If we have free will, then not everything is determined. Everything is determined, so we don't have free will, right? It's logically speaking, when you look at the form, it's logically valid, right? There's no formal fallacy here, right? If those premises are true, the conclusion would follow. If it's really true that having free will means that not everything is determined, and if it's really true that everything is determined, then it would have to be true that we don't have free will, right? So again, logically speaking, the conclusion follows from the premises. If those premises were true, the conclusion would have to be true. Right? It's a big if, right? Like we just got done talking about, premise number one might be a false dichotomy, right? You see that? If we have free will, then not everything is determined. Perhaps that's a false dichotomy. That's assuming that free will and determinism can't both be true, right? But that's another matter, right? That's where I'm focusing on the truth of the premises for that, but deductive validity has nothing to do with that. For deductive validity, all you need to say is, if those premises were true, would the conclusion have to be true? Right? In this case, yes. If both of those premises are true, the conclusion would have to be true. This is just another example, right? Just these examples where if the premises are true, the conclusion must be true. That's deductive reasoning. Whereas inductive reasoning, if you have a good, strong argument, right, we're not going to use the word valid for inductive reasoning. Okay? Did everyone hear that? Valid and invalid, that only applies to deductive arguments. Okay? When we talk about inductive arguments, it's about being strong or weak. So a good argument, a good inductive argument is very strong. And what that means is that if the premises are true, the conclusion is really, really likely to be true. Right? That's a strong inductive argument. Right? So the conclusion is probably true if the premises are true. Okay? So the conclusion is not guaranteed in a strong argument. The conclusion, in fact, may end up being false. Right? That's logically possible in an inductive argument. Right? So listen to that very carefully. This is going to come up in the final for sure, that people get this wrong. Okay? You could have a strong inductive argument with true premises and a false conclusion. It's possible. Okay? Doesn't happen all the time, but it's possible. Everyday example. Right now, you have very strong evidence that you are awake and sitting in front of your device, right, thinking about all this stuff. Very strong evidence, right? You've got a very strong inductive argument that you really are awake and enjoying waking life. And yet, it is possible, right? We talked about this before. You get all that same set of premises, and yet sometimes we think we're awake, but we're actually dreaming. Right? You might have the same set of premises. You're looking around you, everything looks normal, right? And yet the conclusion could be false. Okay. Now that's going to be the exception. Usually, in a strong inductive argument, the conclusion is very likely to be true, and indeed it turns out to be true most of the time when you have a strong inductive argument. It's just that it's possible for the conclusion to turn out to be false, right? You might have very, very strong evidence that it's going to rain tomorrow, right? You might be a meteorologist who just has very, very strong inductive evidence that it's going to rain tomorrow, and yet it doesn't. It happens sometimes, right? So the conclusion of an inductive argument could be false, even if the premises are true. It necessarily follows is what you would say in a deductive argument, right? Yes. In an inductive argument, you'd say something like, it probably follows, right? It's highly likely that the conclusion is true, but not necessarily. Right? Necessary means logically necessary. It means if the premises are true, there's just no way for the conclusion to be false. You could look at it as logically contradicting yourself, right? When you have a valid argument with true premises, you can't make the conclusion false because you'd be contradicting the premises. Whereas in an inductive argument, that's not the case, right? Here's an example. The service at Arby's is always bad. I bet you the next time I go there, it's gonna... it's always bad. Every time I go there, the waiters are rude and unprofessional. Right? You see how that's inductive? This person, every time they go to Arby's, it's been bad. So then they conclude the service is generally bad, right? So it's a type of prediction that they're making. They're saying Arby's service is always going to be bad, right? Why? Because every time I've gone there, it's been bad, right? They've backed up their conclusion with reasons that are relevant to the conclusion. Not necessarily the strongest arguments, right? But it is an argument, and they are presenting premises to support the conclusion. It's just that the conclusion only follows as a matter of probability. It's probably... Now, in this case, it's a little, it's the person making the argument. It's from a very subjective personal point of view, right? Do they mean it's going to always be bad whenever they go to Arby's? Is it a particular Arby's that they go to? All sorts of questions here, right? So this is not necessarily meant to be a good or bad argument. It's just supposed to show you that even if the premises are true, the conclusion could still be false. Right? But we don't just write it off as a bad deductive argument. We recognize that it's an inductive argument where we have to evaluate the strength of the argument. No, we're not really doing fallacies anymore. Right? We've moved on to inductive reasoning. Yeah. Yeah. It's Arby's after all, right? Yeah. Pretty strong argument. Here's a different kind of inductive argument. Chimpanzees are very similar to humans biologically, right? It's true. So if a certain drug, when given to a chimpanzee with a particular type of cancer, makes that chimp better, then it will probably do the same for humans with the same type of cancer. That's called an analogical argument, an argument from analogy. And we do use this kind of reasoning when we do medical testing, right? I mean, that's the whole operating principle behind testing on animals for human products, whether it's cosmetics, unfortunately, right, or something more pressing like medical procedures or drugs or things like that. We test them on animals because we think that they are relevantly similar enough to us, right? Now, of course, it's going to break down in certain cases, and mice might end up being different in some relevant regard, or even chimpanzees who are very similar. It may be that their bodies are somehow slightly different, so that the drug ends up not working on humans. It's always possible, but there's enough of an inductive push to this. There's enough of an inductive argument behind this to think that, well, other biological organisms are pretty similar to us. So if they have similar issues, and certain drugs target that, then they might do the same in us. But it's a might, right? It might do that. There's a higher chance that it'll work than not, perhaps, right? But it's always possible that you're wrong. A very straightforward causal kind of inductive argument. Right? Whenever I heat water in a pan, the water eventually boils. So if I heat water in a pan now, it'll boil again. It'll boil eventually. Notice that this is inductive, even though it seems so inevitable, right? It seems very inevitable, doesn't it, that the water will boil if you heat it in the same way as you have in the past. You almost can't avoid it, but it's not logically, right? It's not logically predetermined that the water will boil. It's logically possible. This is a famous problem in the history of philosophy. It's the problem of induction. And David Hume, the philosopher David Hume, talks quite a bit about this. It's this idea that causal statements, we almost take them to be like logical statements, right? If A happens, then B happens. A happens, therefore B happens, will happen. But strictly speaking, that's inductive, right? You don't know the future. It could be that I put the pan with the water on the fire, turn the fire on, nothing happens. How likely is that? Not likely at all. But is it logically possible given the truth of the premises? Yes. Even if it's true that something's always happened in a certain way in the past, it doesn't logically entail that it's going to be like that in the future, right? That the future will resemble the past is not a logical truth. Right? It's an inductive kind of truth. We think that it's very probable. But even to make the judgment that it's probable, you have to rely on induction. So you can see how this gets to be problematic if you think about it too much. But here, the main gist is, what do these all have in common? Well, even if the premises are true that these arguments are starting out with, the conclusion could still be logically false. It's logically possible, even if it's very unlikely, perhaps physically impossible, right? Perhaps water must boil physically. Sure. But logically speaking, the premises could be true that you've always boiled water in the past, but it could be, logically speaking, It's not contradicting that if you do it tomorrow and it doesn't work tomorrow, right? Tomorrow is a different day, a different time. Right? All your premises just talk about what happened yesterday. Right? So we're making a prediction as to what's going to happen tomorrow, and it might be a prediction that we can know with a high degree of certainty, but not 100% certainty, right? As we could in a deductive argument, where as long as you're sure that the premises are true, the conclusion must be true. In inductive arguments, it's not the case. But notice that that's not really that bad, okay? Unless you get into this, and unless you start studying philosophy and start really thinking about this. But if you think about it, most of your everyday beliefs are derived inductively. Most of the stuff that you base your decisions on are, technically speaking, tentative propositions, tentative beliefs that are only probably true based on your prior experience. Yeah, Maggie, it's the same sort of thing, heating it in the sunlight, right? Yeah, you would think that would happen because in the past it's happened, right? If it's really sunny and hot out and I put a glass of water out in the sun, eventually the water will get warm. That's my prediction. Why? Because in the past it's always done that. But do I know that it's going to happen with 100-degree certainty, or is it only a probabilistic claim, right? Well, if we're reasoning inductively, it's only probabilistic. Yeah, it does, right? It seems like, yes, but it's not actually, you can't derive it logically, right? You can't prove it, basically. Yeah, that's why it's strong. It's just very likely to be true. And so it's not necessarily a bad thing for it to be probabilistic in this way. Most of our beliefs are like that. Most of our beliefs are based on inductive reasoning. Right? And so we always have to take your own beliefs with a grain of salt. You can act on strong arguments, right? On strong inductive reasoning. It's good enough. It's good enough for everyday situations. Yeah. So the whole thing of, heating water in the sun, you completely expect that it's going to happen, but that expectation is psychological. It's not logical. Right? There's no way that it's logically proven by what has happened in the past. Not in a deductive way, only in an inductive way. You can't help but expect the water to get warm. And I'm going to make a bet. It will get warm, right? But my certainty there is based on inductive reasoning rather than deductive reasoning. Even if the water has always gotten heated up in the past, that does not logically entail that it will do that in the future. Okay. Why? Well, because they're not logically contradictory. Right? Something can happen at one time and something else happens at another time. No problem. Okay. Okay, Connie, so you just joined us. Okay, good. Well, I'm glad you showed up, Connie. Good. Welcome. Glad you're here. Okay, so that's inductive reasoning in general, right? The pattern is just that, right? In a good inductive argument, i.e. a strong inductive argument, if the premises are true, then the conclusion is probably true, right? Probably true. So just remember that probably. That's the big difference. In a deductive argument, if the premises are true, then the conclusion is definitely, necessarily true. In an inductive argument, if the premises are true, the conclusion is probably true, most likely true, right? And here, sometimes you'll have to bring in numbers to it, because what do you mean by likely, right? If something is 55% likely to be true, then it's more likely than not. But how probable is that, really, right? If you have a 55 degree probability of getting across the street safely, Are you going to take that risk if it's only 55%? It's more probable than not that you're going to end up on the other side of the street, but that's not a very strong argument, is it? Right? So you have to think about relative strength, right? How strongly is your conclusion actually supported? Right? So if I figure out that my likelihood of surviving crossing the street is 55%, yeah, it's more likely that I'll survive than not. But I'm not very likely to act on that, am I? I'm going to take it as not strong enough of an argument, right, to make it safe. This all reminds me, last night, it's kind of a random thing, but I live on Wabash and West Wabash, and outside I heard this big crash, like a bunch of glass fell, and just a huge crash sounding, and a car speeding off. And then very soon afterwards, I start hearing other cars coming by, rolling right over all that broken glass. Just car after car after car. My wife called the non-emergency line. Some cops came out and cleaned it all up. It's pretty crazy, though. Okay, so the three different examples that I gave you here are actually indicative of the three types of inductive reasoning that we'll look at. Okay, so these are going to be your big intimidating phrases here, right? People who get scared of new content. Enumerative induction. Ooh. Analogical deduction and causal arguments. Okay. These are all different types of inductive reasoning. Even though analogical, it's called deduction, they're still inductive because the conclusion still is only a probabilistic conclusion based on the premises. Okay, we'll see that later. This is slightly out of order from the book. I think the book starts with analogies, analogical arguments. I'm going to start with enumerative. Okay, so we'll just dip our toe in that today. So enumerative induction is where you're reasoning from premises about individual members of a group to a conclusion about the group as a whole. Okay? So that example that I gave you earlier. The service at Arby's is always bad. Why? Well, every time I go there, the waiters are rude and unprofessional. Right. So here, the group is service at Arby's, right? That's the group. All the times that you have service at Arby's, count them all up. Are they all going to be bad? This person says yes, because all the experiences I've had at Arby's have been bad so far, right? So the individual members of a group in this case is each of those experiences at Arby's, right? Each of those times that they've had service at Arby's. That's the members of the group. The group as a whole is service at Arby's in general, right? So they have individual members of the group. I went to Arby's that day. I went to Arby's that day. I went to Arby's that day, right? My service was bad this day. My service was bad that day. My service was bad this day. My prediction is the service is bad in general. You know? And for each of, so I'm giving you the quick rundown right now, and then for each of these, we'll zero in on them. Okay, I do this sometimes, right? Just to give you a taste of what's coming. So right now I'm going over it quickly, but then I'll go over it slowly. Okay. Analogical induction, right? Inferring that that since these two things are similar in certain ways, they must be similar in other ways, right? That was the example that we looked at with the chimpanzees or animal testing in general, right? Where you make a conclusion based on similar characteristics, right? That if we share certain characteristics, then there's a higher chance at least that we share other characteristics as well. And then finally, causal arguments. And those are inductive arguments, right? Where the premises support some sort of causal claim, right? Like this one. Whenever I heat water in a pan, right? The water eventually boils. Right? So I've had this experience of, again, right, correlation pretty much, right? But we tend to think of that kind of correlation as causal, right? Whenever I put water in a pan over some sort of heat source, the water starts boiling. That's happened in the past. Those are my premises. And then I'm going to make a prediction. If I do the same thing now, put water in the same pan, the same heat, everything else is still the same, then the water will boil eventually. Very strong arguments. Right? It's hard to convince yourself that anything else would happen, right? But at the same time, can you imagine, right, a logical possibility? Remember when we looked at valid arguments or at propositional logic, and I'd have you look at these 4 different corners of logical possibility, or however many corners there were, right, of what's actually logically possible? Well, can you imagine a world where you turn the heat on, you put the water in it, and you just sit there and wait and wait and wait, and the water doesn't do anything? Can you imagine that? Yes, I imagine that you can, right? Even though that's so silly, you can just dismiss it in a way. But that means that it's not deductive reasoning that you're using. Right? Because with deductive reasoning, that would involve you in a contradiction, right? But there's no contradiction with saying the water boiled yesterday, the water's not boiling today. There's no contradiction. So that means it's not a logically valid deductive argument, right? When you predict that the water is going to boil again, and you can apply this to any everyday thing that you use, right? Turning your car on with your keys, whatever it may be. It's logically possible that something else might happen than what's happened in the past. And so that makes it inductive. And that means you can only really say that your prediction is strong or weak, right? But it does not necessarily follow, right? It doesn't follow as a matter of logic anyway. Okay, so I think rather than start this whole chunk, I think maybe we'll stop right there because we only have about 7 minutes left. So I don't know that I could do much of this. And maybe I'll just do this part right here. Okay, we'll just get started on this. So again, this is what we're doing. This section on inductive reasoning. This is what we're going to be looking at. These 3 different types of inductive arguments. Enumerative, analogical, causal. When we're done with that, we'll look at inference to the best explanation, and then we'll be done. Okay? Just to remind you, we're doing these 3 things, right here, and then one more thing. Then we'll be done, right? So we'll do this this week, and then possibly a little bit next week, and then we'll finish with our last section, argument from the best explanation, or inference to the best explanation next week. Okay, yeah, so very much almost there. And so this seems intimidating maybe, but this is it, right? So we're going to look at each of these 3, and then one more thing, and then we'll be done. So let me just quickly start enumerative induction. All right, so you're reasoning from premises about individual members of a group to conclusions about the group as a whole. Right. In other words, you're making a general inference on the basis of particulars that you've experienced. Right, like the Arby's example. But what about this one? All the crows that I've ever seen have been black. So all crows are probably black. 75%, there's a typo there. It says CR twice. 75% of CR students that I've talked to have brown hair. So probably about 75% of CR students have brown hair. Yeah? You see that you're starting out with a limited sample where you haven't actually had service at all the Arby's, right? All the services at every Arby ever. You haven't experienced those. You've experienced a limited set. You haven't seen all the crows that exist in the world. You've experienced a limited set. You haven't talked to all the CR students and observed their hair color. You only did that with a limited set. But now you're extrapolating. You're saying, well, on the basis of that experience, I'm going to extrapolate about the group as a whole. Yeah? And you can do this in good ways and bad ways. Okay, so I'm not going to get into the next part. I'll leave it at here. Okay. Do you see generally what's going on in this type of reasoning? We'll get into this a little bit. Surveys are very much relevant here, right? Surveying, taking polls on who people are going to vote for, that sort of thing. It's very much based on enumerative induction. You know. Before I get into it more, you might also recognize that it's very easy to go wrong here. Makes sense, hopefully. Hopefully, I like that. People come up with conclusions about whole groups of people, for example, right, on the basis of limited experience. That you can see how that could be very problematic, right? So yes, it's all a matter of probability, right? Yes. You're making judgments, you're making predictions based on previous experience. That's basically what it is. But it usually has to do, in this case, experience with a limited sample and then extrapolating beyond that, right? As a matter of probability. We do this kind of stuff all the time. I mean, you might think about your own life and your own experiences, right? Are there certain things you won't ever do again? Are there certain things you are now going to avoid because in the past they've been troublesome, and you think that there's a high degree of likelihood that these things will be troublesome again, right? Yeah, things like that does happen. What Anna's talking about, right? People have some sort of personal bad experience, or the sample just isn't representative. We'll get into that as well, right? People who talk about pit bulls being mean, I mean, a lot of that just has to do with public perception, right? A lot of that just has to do with false ideas that people have about pit bulls that get transmitted over the internet and stuff like that. Yeah, exactly. Yeah, that would be a mistake, right? Yeah, because again, for that we have to talk about sample representativeness and stuff like that, and that's going to be the next section where we explain this more. So yeah, you're getting into the right idea, though. That's right, because there's ways to do this right, and there's ways to do this wrong, right? So I don't ever want you to think that inductive reasoning, because it isn't deductive, because it's possible for an inductive argument for the conclusion to be false, even if the premises are true, that doesn't mean it's some sort of downgraded version of reasoning or something like that. This is essential reasoning that we use all the time. There's no way that we cannot rely on it, right? It's just a matter of extrapolating in the correct way and not coming up with conclusions that are not supported very well, right? That don't have strong arguments in favor of them, right? So number one, for example, is a pretty bad argument, right? We don't know which Arby's this person has been going to. Is it just one in the whole world, right? How many times they've gone? Like, what if they just went to their local Arby's twice? And it just happened to be two waiters that were fired soon after, right? Obviously, that person's experience is not enough to conclude that the service at Arby's is generally bad. Okay. And even number two, right? You could see that this is scientifically, okay, well, let's say all the crows we ever see are black. Um, you can make a prediction that all crows are probably black, but you could very well easily imagine, even more so than the water example, coming across a white crow, right? See something that's genetically the same, moves the same, everything, but it just happens to be white. It's not logically impossible. It's just very, very unlikely based on all our experiences with crows in the past. Yeah. Okay, well, let's stop there then. 1125 is our stopping point anyway, and this is a good stopping point. So, remember where we're at, right? We finished propositional and categorical logic. Those are deductive type of reasoning. Now we're looking at inductive reasoning, and we're going to zero in on these three different types of inductive arguments and sort of how they work and how to evaluate them. And then at the end of the semester next week, we will look at inference to the best explanation, and we'll use some of the sort of the guiding values that science uses that you can actually apply to your own life and to your own reasoning. Then we'll stop there unless you have any questions. Have a nice day.
I had a question just about your about trying to transfer over credits. It's not a class question about this class. It's more about